The lesson that we will be tackling today is limits of exponential and logarithmic functions. Let's start by defining a few terms. Exponential functions is defined as f of x is equal to a times b to the power of p of x plus h, where a, b, and h are all real numbers. A is not equal to 0, b is greater than 0, and p of x is a polynomial in x. Logarithmic functions is defined as f of x is equal to log x to the base b, where b is greater than 0 and not equal to 1, and x is greater than 0. Logarithmic functions are also known as the inverse of exponential functions, in the form b to the power of x is equal to y, and log y to the base b is equal to x. For example, if b is equal to 5, and the exponent, which is x, is equal to 2, y would be 25, because 5 squared is equal to 25. So log 25 to the base b, or 5, is equal to 2. What is a limit? It is the behavior of the function as x approaches to a certain value. The idea of a limit is the basis of all calculus. If we were to find the limit of x squared minus 1 all over x minus 1 as x approaches to 1, we would have to find the value that y approaches to as x goes closer and closer to 1. As you can see in the table, on the left side of x, as it approaches to 1, the value of y also goes closer and closer to 2, and on the right side of x, or 1, as x approaches to 1, the value of y goes closer and closer to 2 also. So the limit of x squared minus 1 all over x minus 1 as x approaches to 1 is equal to 2. Here are a few examples of finding the limits of exponential functions.
So today we will be discussing about the limits of exponential and logarithmic functions. So to start the discussion, I'd like to use a simple problem which is limit of 5 raised to the power of x plus 3 as x approaches positive infinity. It is important to take note of the sign of the infinity symbol as it may affect the solution and answer of the problem. For problems like these, we can evaluate the function directly. So basically, we now have 5 raised to the power of positive infinity plus 3. And in order to understand this problem, let us refer to the table below. So we need to take note of two things in the table. It's the relationship of x with f of x, which is that as x increases, f of x increases, and the fact that x is approaching positive infinity, which means that as x approaches positive infinity, f of x approaches positive infinity too. Therefore, 5 raised to the power of positive infinity is just positive infinity. And now that we have positive infinity plus 3, it is important to remember that infinity is a concept wherein there is no definite value, it is a very large number, and it is something without any bound. And that an infinitely large number, plus or even minus a number, is still an infinitely large number. Therefore, positive infinity plus 3 is just positive infinity. Now that we understand how to solve problems like these, we may use basic concepts we've learned to solve more complex problems.
So for the next example, we have the limit of negative 16x to the power of 9 plus 16x to the power of 9 e to the power of x all over 4 squared times x to the power of 10 as x approaches to 0. So what we would want to do is have an n fraction of e to the power of x minus 1 over x, because we know for a fact that the limit of e to the power of x minus 1 all over x as x approaches to 0 is basically 1. So we can do so by first extracting something common between the numerator and denominator. So 4 squared, this is basically 16. So what we can extract from the numerator and denominator is 16x to the power of 9, because it's common between numerator and denominator. We can then cancel 16x to the power of 9 on both numerator and denominator, so it will make it 1. Now that we have reached this point, we can rewrite this fraction as e to the power of x minus 1 all over x. Again, to reiterate, the limit of e to the power of x minus 1 all over x as x approaches to 0 is just 1. Therefore, the limit of negative 16x to the power of 9 plus 16x to the power of 9 times e to the power of x all over 4 squared times x to the power of 10 as x approaches to 0 is basically 1. Yay! Easy peasy.
For our third problem, we have to find the limit of 5x cubed e to the power of x minus 5x cubed plus 2e to the power of x minus 2 all over 4x as x approaches 0. The first thing we have to do is find the factors of the numerator, which are 5x cubed plus 2 and e to the power of x minus 1. Next, we factor out 4 from the denominator. So now we have 1/4 times the limit of 5x cubed plus 2 as x approaches 0 and the limit of e to the power of x minus 1 all over x as x approaches 0. The limit of e to the power of x minus 1 all over x as x approaches 0 is just equal to 1. And we substitute 0 for the value of x in 5x cubed plus 2. Note that the value of x is not exactly 0. It is just very, very close to 0. So now we have 1/4 times the quantity of 5 times 0 cubed plus 2 times 1, which is equal to 1/4 times 2. So the limit of 5x cubed e to the power of x minus 5x cubed plus 2e to the power of x minus 2 all over 4x as x approaches 0 is equal to 1/2.